looking at number 4, it's still a right triangle. So I do still have a hypotenuse that I don't know, but I don't care about it. So again, not the Pythagorean theorem. The thing I'm trying to find is an angle. So we will solve this with inverse, the little -1. So let's figure out which trigonometric function we will be using. I have the opposite leg, I have the adjacent leg, but I don't care about the hypotenuse. SOHCAHTOA tells me that if I have the opposite and the adjacent, I will be using a tangent ratio. So I don't know the angle that I wrote those labels from, so I'm just going to call it x. But I do know it's always the ratio of the opposite leg to the adjacent leg. To get x by itself, we take tangent inverse of both sides of the equal sign. So remember, this looked like I can take tangent inverse of tangent x. I'm going to take tangent inverse of 23 over 45. So this side cancels. So I'm going to find x by just figuring out what is the tangent inverse of 23 over 45. So I have to type in my backwards calculator, 23 divided by 45, and I'm going to hit equals, and then second tangent to get that little -1. And since it's an angle, I'm going to say it's about 27 degrees, because the directions say nearest degree, which just means nearest whole number, whereas when we found the side earlier, it said nearest tenth. So I did a decimal to the nearest tenth. This one is also a side, so we're going to get a decimal to the nearest tenth. Specifically in this right triangle, I don't know the hypotenuse. But since I also don't know one of the legs, I can't do the Pythagorean theorem. I do know an acute angle, so I can do SOHCAHTOA. The opposite leg is the blank one, so I'm not going to use the opposite leg. The adjacent leg gets next to my angle is a 17. SOHCAHTOA tells me this will be a cosine ratio. So I'm going to take cosine, I'm going to say what angle it is that I used, and then I'm going to say what ratio it has to equal. And it's always adjacent over hypotenuse. Since it's a side, I'm going to cross multiply. 17 times 1 is 17. X times the cosine of 43 is x times the cosine of 43. And since I don't want to have that times cosine 43 there, I'm going to divide by the cosine of 43, and I'm going to do it to both sides of my equal sign. So I'm going to type in, and I'm getting 23.24-ish. So I'm just going to say it's about 23.2 for that side length. And then the last one of these review problems. It's yet again another right triangle. I'm not finding a missing side, so it's not going to be the Pythagorean theorem. I'm finding an angle, so we'll be doing inverse. Specifically, since the hypotenuse is given to us and this side right next to my angle is given to us, we're going to end up solving with a cosine ratio, but that's not how I'm going to start my equation. I always start the same. Cosine of my angle equals this fraction. My angle is x, so it equals the fraction of 31 over 33. I'm going to solve. I'm going to undo cosine by taking cosine inverse. And if I do it to the left, I have to do it to the right. So x will be found by taking cosine inverse of that fraction. And my calculator says 20.04, so it's just about 20 degrees. We really need to make sure we're adept at figuring out how to solve, which trig functions we use, because the rest of these problems don't have pictures, so really the only new thing is put a picture in there.